Determinants, properties of determinants. So in this video we are going to learn some of the properties of determinants which simplifies its evaluation by obtaining maximum number of zeros in a row or a column. These properties are true for determinants of any order. What is the meaning of the first statement? We will study some properties of determinants which simplifies its values. That means by using properties of determinants, we can evaluate the determinant, right? The values will get simplified. So we are using the properties of determinants in the evaluation process. In the evaluation process to make the values as simple. How to obtain maximum number of zeros either in a row or a column. Either in a row or a column. So when we apply the properties of determinants to evaluate the given determinant, the values will get simplified. The values will be getting simplified. That means you will get maximum number of zeros in a row or a column. You will get a maximum number of zeros in a row or a column. So if you get maximum number of zeros means then we can evaluate the determinant easily, right? So this is the objective of today's class, and these properties are true for determinants of any order. These properties are true for determinants of any order. However, we shall restrict ourselves up to determinants of order 3 only. So we are going to discuss the properties of determinants of order 3 only here, right? So that is the objective of today's class. Now I move on to the properties. Property number 1. The value of the determinant remains unchanged if its rows and columns are interchanged. So what is the first property? The value of the determinant remains the same even if the rows or columns are getting interchanged. If you interchange the rows and columns, then the value of the determinant does not change. There will be no change in the value of the determinant even if the rows and columns are interchanged. So that is the first property. Okay. We will use all these properties when we solve problems. So these properties are very important, right? So what is the first one? The value of the determinant remains unchanged. That is, remains the same if the rows and columns are interchanged. Okay. Let us prove this property. See the proof. Let delta is equal to, I am taking the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3 as delta. Okay. I am considering this determinant in order to prove the given statement. Okay. This determinant is of order 3. Why? Because there are 3 rows and 3 columns, right? We can see 3 rows and 3 columns. The first row is A1, A2, A3. Second row is B1, B2, B3, and the third row is C1, C2, C3. Okay, and these are the columns. So the given determinant is of order 3. It's a 3 cross 3 determinant, right? Now I am going to expand this determinant along first row. Along the first row. So what is the first row here? A1, A2, A3. I am going to expand this along the first row. So what you will get? Delta is equal to A1. You delete the row and the column having the element A1. Okay. So what you are getting is the 2 by 2 determinant B2, B3, C2, C3. Okay. In the next position, what is the next position? 1, 2 position. In 1, 2 position, we have the element A2. For this position, you will be getting minus sign because this is 1, 2 position. No? So, Aij plus minus 1 whole to the power I plus j. Okay, so for 1 2 position you will be having minus 1 whole to the power 1 plus 2, right? So minus 1 whole to the power 3, it becomes minus, right? So minus A2, if you delete the row and the column having the element A2, then you will be getting the determinant B1, B3, C1, C3. It's a 2 by 2 determinant. Then in 1 3 position we have the element A3. For this position you will be having positive sign. So plus A3 into, if we delete the row and the column containing the element A3, then you will be getting the determinant B1, B2, C1, C2. This is also of order 2. Okay. Now expand this. So A1 into, in the downward arrow this is B2, C3, minus in the upward arrow this is B3, C2. Here we have minus A2, and if you simplify this, then this is B1 C3, and in the upward arrow this is minus B3 C1, plus here we have the element A3 into, this is B1 C2 minus C1 B2 in the upward direction. Okay, so this is the value of delta. So this is the value of the determinant delta. Okay, now in delta, I am going to interchange the rows and columns. In delta, I am going to interchange the rows and columns. So I will get a new determinant. I will get a new determinant. Then I will find the value of the new determinant. After that, I will check the values of these two determinants, that is delta. If the new determinant is delta 1 means, then I will check the values of delta and delta 1. If the values are not changed, remains unchanged. Okay, if the values are not changed, then we have proved this result, right? So I'm going to interchange the rows and columns of delta, then we get the determinant delta 1. In delta 1, the first row is A1, B1, C1. That is, in delta, the first row is actually A1, A2, A3. Okay, this is what delta. Second row is B1, B2, B3. Third row is C1, C2, C3. Okay, so the first row is written as first column here. A1, A2, A3. The second row is written as second column here, B1, B2, B3, and the third row becomes the third column of delta 1. So here the rows and columns are interchanged. In delta 1, the rows and columns are getting interchanged. We have interchanged the rows and columns of delta, so we are getting the new determinant delta 1. What is delta 1? It is determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. Now I am going to expand this new determinant delta 1 along the first column. Along the first column. What is the first column here? A1, A2, A3. Right? So we get delta 1 equal to A1 into, if we delete the row and the column having the element A1, then you will be getting the 2 by 2 determinant B2 C2 B3 C3. So in the downward arrow this is B2 C3 minus in the upward arrow B3 C2, right? Next element in the first column is A2. That is A2 is in A21 position. A2 is in A21 position. So for this position also we will be getting minus sign. Minus 1 whole to the power 2 plus 1. It becomes minus 1 cube, right? Minus 1 cube. So minus. minus A2 into, if you delete the row and the column having the element A2, then you will be getting B1 C1 B3 C3. So in the downward arrow this is B1 C3 minus in the upward arrow this is B3 C1 plus the next element, that is in A31 position. Okay, in 3 1 position we have the element A3. For this position you have positive sign, so plus A3 into, if we delete the row and the column having A3, then you will get B1 C1 B2 C2. So in the downward arrow this is B1 C2 minus in the upward arrow this is B2 C1. Okay, so what is this? This is nothing but delta, the value of the given determinant. Am I right? So here the value of the determinant remains the same. Value of the determinant remains the same even if you interchange the rows and columns. Okay, so what we have considered here, we have considered a 3 by 3 determinant. Okay, first we have found the value of delta. Delta is the given determinant. Then we have interchanged the rows and columns of delta. So we got the new determinant delta 1. Then we have found the value of delta 1. Now we identified that the values of delta and delta 1 remains the same. One and the same, right? So what is our conclusion? Delta is equal to delta 1. So this is what property number 1. Let us see one example for this property. Verify property 1 for delta is equal to determinant 2 minus 3 5 6 0 4 1 5 minus 7. So this is the given determinant. We have to expand the determinant along the first row. See the solution. This is the given determinant delta. Okay, I am going to find the value of delta. For that, I am expanding the given determinant delta along the first row, right? So what is delta? 2 into, if you delete the row and the column having the element 2, then you will be getting 0 4 5 minus 7. 2 by 2 determinant. Then in the next position, that is in 1 2 position, we have the element minus 3. And for this position you will have minus sign, so minus of minus 3, delete the row and the column having the element minus 3. Okay, so you will be getting 6 4 1 minus 7 plus in 1 3 position we have the element 5. For this position we have positive sign, so what you are getting is 6 0 1 5. Okay, now simplify this. So 2 into, in the downward arrow this is 0 minus 5 into 4 20, and this becomes plus, minus of minus 3 becomes plus 3. Here you will get minus 42 in the downward direction. In the upward direction this is minus 4 plus 5 into, here you will be getting 30 in the downward minus in the upward this is 0. So on simplification we get the value minus 28. So I am getting minus 28 for delta. Okay. Here what I am going to verify, I am going to verify that the value of the determinants remains unchanged if the rows and columns are getting interchanged. So I am going to interchange the rows and columns and I am going to verify that. So interchange the rows and columns, we get here the first row is 2 minus 3 5. So that is written as the first column in delta 1. And the second row of delta, that is 6 0 4, is written as second column of delta 1. And the third row of delta is 1 5 minus 7, that is written as the third column here. Okay. Next we are going to find the value of delta 1. Okay. So what is delta 1? You expand along the first column. okay, as in the property. So you'll be getting this 2 determinant 0, 5, 4, minus 7, and this is minus of minus 3. Determinant 6, 1, 4, minus 7 plus 5 into determinant 6, 1, 0, 5. So on simplification, we are getting the same value here, minus 28. So it is clear that the values are not changed, remains the same. So delta is equal to delta 1, hence property 1 is verified. Next, property 2 is if any two rows or columns of a determinant are interchanged, then sign of determinant changes. What does it mean? If any two rows or columns of a determinant are interchanged. If you interchange the rows and columns, not all the rows, any two rows. Okay, any two rows or any two columns of the given determinant, then there will be a change in the sign. That is the meaning of this property. So if you interchange any two rows, or any two columns, okay, you interchange any two rows or any two columns of a determinant, then the sign of determinant changes. There will be a change in the sign, not in the value. There will be a change in the sign. So this is the difference between the first two properties. In the first property, if you interchange the rows and columns, then the value of the determinant will not be changed. But here, if any two rows or columns are getting interchanged, then there will be a change in the sign, not in the value, right? So we are going to prove this property. Consider delta is equal to determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. As we have discussed earlier, we have considered only the determinant of order 3, right? So delta is of order 3 here. Now expanding along the first row. So what we are getting is delta is equal to A1 into determinant B2, B3, C2, C3 minus A2. We are expanding along the first row. So minus A2, if we delete the row and the column having the element A2, then you will be getting this determinant B1, B3, C1, C3. In the next position, we have the element A3 in the first row. For this position, you have positive sign. And if you delete this element, that is if you delete the element if you delete the row on the column having the element A3, not deleting A3, right? So then you will get B1, B2, C1, C2. Now simplify this. What are getting? C B2, C3 minus B3, C2. Next minus A2 into, in the downward arrow, this is B1, C3 minus upward arrow B3, C1 plus A3 into, this is B1, C2 minus B2, C1. Okay, so this is the value of delta. Now I am going to interchange the first and third rows here. I am going to interchange the first and third rows here, because what I am going to verify is, I am going to verify that if two rows or two columns, any two rows or any two columns of the determinant are getting interchanged, then whether there is a change in the sign. Okay, so I am interchanging the two rows. What are the two rows? First and the third row. Okay, then the new determinant is obtained by delta 1 equal to, what is delta? Delta is A1, A2, A3. First row, B1, B2, B3. Second row, C1, C2, C3. Third row. So this is our delta. Now I am interchanging the first and third row. First row is, what is the first row? First row is represented as R1. Okay, so A1, A2, A3 is the first row, and the third row is denoted by the symbol R3. Okay, R refers rows. Okay, and this is the order of the row. So R3 elements are C1, C2, C3. So interchanging these two rows, you are getting a new determinant, which is delta 1 is equal to C1, C2, C3. These two rows are getting interchanged here. So C1, C2, C3, R3 becomes R1 now. The third row becomes the first row, and the first row becomes the last row, or the third row. Okay. We have not changed the second row, so write as it is. No change in the second row, so B1, B2, B3. So this is your new determinant. Now I am going to expand this determinant along third row, Why we are expanding along third row? Because in delta we have the values A1, A2, A3, right? So to get this, we are expanding this determinant along the third row. Okay. So in the third row, the first element is A1. Now, if you delete the row and the column having the element A1, then you will be getting B2, C3 in the downward, not B2, C3, B3, C2. Okay. B3, C2 minus in the upward direction, this is C3, B2. C3, B2. Okay. In the next position, that is in A32 position. In A32 position, we have the element A2. This is 32 position. For 32 position, we have minus sign. So minus, the next element is A2. So if you delete the row and the column having the element A2, okay, then you will be getting C1, C3, B1, B3. So in the downward, this is C1, B3. C1, B3. Okay. C1, B3 minus C3, B1. Okay. Next element is A3. That is A3 is in 3 position. So for this position we have positive sign. If we delete the row and the column having the element A3, then you will be getting C1, B2, C1, B2 minus C2, B1 in the upward direction. Okay. So now I am going to change the sign. That is, I am going to take the minus sign outside from all the three terms. So when you take minus out, then you will be getting the first terms becomes, this is actually B3C2, no? So we are taking minus sign outside from this, then it will become C3B2. C3B2 minus B3C2, correct? Minus A1 into C3B2 plus A1 into B3C2, right? And this becomes plus A2 when you take minus out. Okay, so minus of minus becomes plus, so A2 into, this is C3B1 minus C1B3. Then in the third term I'm taking minus out, so it becomes minus A3 into C2B1, C2B1 minus C1B2, minus C1B2. Okay. Now, if you take minus out from all the three terms, then you will be getting this expression inside the bracket. That is A1 into B2C3 minus B3C2 minus A2 into B1C3 minus B3C1 plus A3 into B1C2 minus B2C1. So this expression is replaced by delta. So what we are getting is delta 1 equal to minus delta. Let us see that. here I am finding the value of delta 1. Delta 1 is this. So I am taking the minus sign out. Then we are getting A1 into B2 C3 minus B3 C2 minus A2 into B1 C3 minus B3 C1 plus A3 into B1 C2 minus B2 C1 inside the bracket. What is this? This is nothing but delta value, right? So this expression is replaced by delta. So what we are getting is delta 1 equal to minus delta. Delta 1 equal to minus delta. So we have verified the result by interchanging the two rows. Similarly, we can verify the same result by interchanging any two columns. Okay. So what is property 2? If you interchange any two rows or any two columns of the determinant, then there will be a change in the sign. Right? This is what property number 2. Next, we see one example for property 2. Verify property 2 for delta is equal to the given determinant is 2 minus 3, 5, 6, 0, 4, 1, 5 minus 7. This is of order 3 as there are 3 rows and 3 columns, right? Already we have found the value of this determinant in example 1. Okay, we have used this determinant to verify property number 1. So already we have got the value of delta in example 1. So I am considering that value here directly without finding the value of delta. Okay, so I am taking it here. It is minus 28. It is in example 1. Okay. Now we are going to find a new determinant by interchanging the two rows R2 and R3. What is R2? R2 is the second row and R3 is the third row, right? So I am going to interchange these two rows. I am going to interchange these two rows. This is R3. This is R2. So R2 will come here. R2 goes to R3. What is the meaning of this bracket? R2 goes to R3 and R3 goes to R2. So the second row is now the third row and the third row becomes the third row is the second row, right? So we are going to interchange this. We are getting the new determinant delta 1. Delta 1 is equal to determinant. Since we have not done any change in the first row, write the first row elements as it is 2 minus 3, 5. The second row is 1, 5 minus 7 and the third row is 6, 0, 4. Expanding the determinant delta 1 along the first row. Okay, we are expanding delta 1 along the first row. Here the first row elements are 2 minus 3, 5. So delta 1 equal to 2 into in 1 position we have the element 2. So if you delete the row and the column having the element 2, then you will be getting the 2 by 2 determinant 5 minus 7, 0, 4. In the next position we have minus 3. For this position we have minus sign. So minus of minus 3. Then if you delete the row and the column having the element minus 3, then you will be having this determinant 1 minus 7, 6, 4. Plus in the next position we have the element 5. So for this position you have positive sign plus 5 into 1560. So on simplification what we are getting, see 2 into in the downward arrow this is 20 minus 0, minus of minus 3 becomes plus 3. Here in the downward arrow this is 4. Here you are getting minus 42 actually, but in the upward arrow you will have minus, so minus of minus 42 becomes plus 42 plus 5 into this is 0 minus 30. Okay, 0 minus 30. So on simplification we are getting the value 28. We are getting the value 28, but what we are getting for delta is minus 28. Delta is minus 28. Therefore what we can write, delta 1 is equal to minus delta. So here property 2 is verified. Okay, property 2 is verified. What is property 2? If you interchange any two rows or any two columns, then there will be a change in the sign. So here we have interchanged the rows. This property can also be proved by interchanging the columns also. Now I move on to property number 3. What is the statement of property 3? Property 3 is if any two rows or any two columns of a determinant are identical means same, okay, then the value of the determinant is 0. This is property number 3. Okay, if any two rows or columns of a determinant are identical, so any two rows or columns in the given determinant are same, right? All the elements are same means then the value will be 0. Value of the determinant will be 0. This is what property number 3. Let us see the proof of this property. The proof is very simple. If we interchange the identical rows or columns of the determinant, then delta does not change. What does it mean? Property 1 says that, what is property 1? The value of the determinant remains the same if the rows or columns are getting interchanged. That is property number 1. So there will be no change in the value when you interchange the rows or columns. So using that property, I can write delta does not change. There will be no change in delta in the value, right? It means that in the value of the determinant delta, there will be no change by property number 1. However, by property 2, it follows that delta has changed its sign. Yes, there will be a change in the sign. What is property number 2? If any two rows or columns are interchanged, then there will be a change in the sign. So using that property, that means property number 2, delta has changed its sign. Therefore, I will write delta is equal to minus delta. Delta equal to minus delta, which implies delta plus delta is equal to 0 or 2 delta equal to 0, which implies delta equal to 0 as 2 cannot be 0. 2 is 2 only, it cannot be 0. So what is the only possibility here? Delta is 0, right? So this is what property number 3. Property 3 says that if any two rows or any two columns, if the elements of any two rows or any two columns are identical of a determinant, identical means are same, then we can put the value as 0. The value of the determinant is 0. Let us verify property number 3 using example 3. What is example 3? Verify property 3 for the determinant delta is equal to determinant 3, 2, 3, 2, 2, 3, 3, 2, 3. See the elements of R1 and R3. R1 is the first row and R3 is the third row. Here the elements of 1 and R3 are same. R1 and R3 are identical. Okay. So now I am going to expand along the first row. So 3 into, if you delete the row and the column having the element 3, then you will be getting 6 in the downward arrow, minus 6 in the upward arrow. In the next position we have the element 2. For this position you have minus sign. So minus 2 into, if you delete the row and the column having the element 2, then you will be getting 6 in the downward, minus in the upward you will be getting 9. In the next position we have the element 3. For this position you have positive sign. So this is 4 minus 6. 4 minus 6. On simplification we are getting 6 minus 6, so it is 0, because this is because of R1 and R3 are identical. This is because of R1 and R3 are identical or same. So without doing all these things, we can directly write delta equal to 0 by property 3. So when you are solving problems, you can write directly that delta equal to 0 if you see any two rows or any two columns, that is the elements of any two rows or the elements of any two columns are the same, means then value of delta is 0 by property 3. You can write it directly without expanding anything, right? So properties makes the computation easy, right? Now I move on to property number 4. What is property 4? Property 4 is if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Okay? If each element of a row or a column of a determinant is multiplied by a constant k, that means we are multiplying the elements of any row or any column by a non-zero constant k. Here k is a non-zero value. So if you are multiplying any row or any column of a determinant by a constant k or non-zero scalar, then the value of the determinant will also be multiplied by k. The value of the determinant will also be multiplied by k. So that is the statement of property number 4. Okay, let us prove this property. Let delta is equal to determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. We consider this determinant of order 3. Okay, A1 B1 C1, A2 B2 C2, A3 B3 C3 of order 3. Now to prove this result. Okay, so what I am going to prove here, if I multiply any row or any column, each element of any row or any column by a non-zero scalar k, then the value of the determinant will also multiplied by the value k. That we are going to prove it here. So I have to find a new determinant in which the values of any row or any column multiplied by a constant k. Okay, so I am writing the new determinant delta 1. In delta 1, the new row, I am getting the new row, that is the first row. It is KA1, KB1, KC1. So what I have done is, I have multiplied the first row of delta. What is the first row of delta? A1, B1, C1. This is the first row of delta. So these elements, the first row of delta, each element of the first row of delta is multiplied by a non-zero constant, non-zero value k. Okay. So you are getting delta 1, it is determinant ka1, kb1, kc1. We have multiplied the first row alone. Okay, so write the second row as it is, a2, b2, c2, a3, b3, c3. Write the next two rows as it is. Since we have multiplied the elements of first row, each element of first row by a constant k. Here k is a non-zero value. It's a non-zero scalar. Okay, so write the next two rows as it is. So this is your new determinant delta 1. Now we have to find the value of delta 1 and we have to check that whether the value of delta 1 is multiplied by k. So expanding along the first row. Expanding along the first row, this is delta 1, right? So in the first position we have the element ka1. So ka1 into, if you delete the row and the column having the element ka1, then what you're getting, b2c3 in the downward minus b3c2 in the upward. Then in the next position we have the element kb1. So for this position we have minus sign, so minus kb1 into, if we delete the row and the column having the element kb1, then you are getting a2c3 in the downward minus a3c2 in the upward, plus in the next position we have element kc1. For this position you have positive sign, so kc1 into a2b3 minus a3. In all the terms we have k, so take it out, it's a common factor. Okay, so k into a1 into b2c3 minus b3c2 minus b1 into a2c3 minus c2a3 plus c1 into a2b3 minus b2a3. So what is this? This is nothing but the value of delta. So this lengthy expression is replaced by delta. Okay. So k delta. Hence, what we are getting is delta 1 is equal to k delta. What is delta 1? Determinant K1, KB1, KC1, A2, B2, C2, A3, B3, C3 is equal to K into determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. So what we have obtained here, when you multiply each element of any row or any column, okay, by a non-zero value, say k, it's a constant, then the value of the determinant will also be multiplied by k. This is what property number, right? Remarks. So by using this property, from property 4 we have arrived these remarks. Okay, what are the remarks? By this property we can take out any common factor. We can take out any common factor. So using this property, we can take the common factor outside from any one row or any one column, from any one of the row or any one of the column of a given determinant. So that is the first point here. Then the second point is, if corresponding elements of any two rows or any two columns of a determinant are proportional. Proportional in the sense they are in the same ratio. If they are in the same ratio, then the value of the determinant is 0. Okay, so this is the second point. What is the first point? Using property 4, we can take the common factor outside from any one of the row or from any one of the column of a given determinant. Then the second point is, if the corresponding elements of any two rows or any two columns are are in the same ratio, that is, are proportionate, then the value is 0. Value of the determinant is 0. For example, if delta equal to determinant a1, a2, a3, b1, b2, b3, ka1, ka2, ka3. See that the first and the third rows. The first row is A1, A2, A3. Whereas the third row is K1, Ka2, Ka3. That is, the second row is obtained by multiplying the first row by the constant k. If each of the element of the first row is multiplied by k, then you are getting the third row. The third row elements are obtained by multiplying the first row elements by the non-zero scalar k. Okay, so these two rows are proportionate or in the same ratio. Okay, here the common factor is k. There's k into a1, k into a2, k into a3. Okay, so these two ratios are proportionate. Therefore, value of the determinant is 0. Right? So this is what we have got from the above property. Now I move on to problems. Problem number 1. Evaluate the determinant 102, 18, 36. This is the first row. Second row is 1, 3, 4. And the third row is 17, 3, 6. Okay. We have to evaluate this determinant. That means we are going to find the value of the determinant. Okay. So how to do that? Using properties. So what property I can use it here? First, check the values of the given determinant. See the values of the determinant. Here I have 102, 18, 36. These values are bigger values when comparing the other values, comparing with the other two rows. Okay, the values given in the first row are very big. Is there any relation between the first and the second row or first and the third row? That we have to check first. Okay. Yes, there is a connection between the first and the third row. 102 can be written as 6 into 17. 17 6 are 102. And this 8 can be written as 6 threes. 6 threes are 18. And this 36 is written as 6 into 6. 6 6 are 36. Right? So these are multiples of 6. These elements are all multiples of 6. Right? So how we can express it? 6 into 17. 6 into 3. 6 into 6. So here the first row and the last row are proportionate, right? And the common factor from the first row is 6. The common factor from the first row is 6. So using property we can take it out. So 6 into determinant 17 3 6 1 3 4 17 3 6. Here these two rows are identical, same. Therefore value of the determinant is 0. So without expanding, here I have not expanded the determinant to find the value. So without expanding the determinant, we are writing the value of the determinant using properties. So properties are helpful to find the value of the given determinants. So actually we have used the above property here, right, in problem number. So that is the example for the above remark. And I move on to property 5. What is property 5? If some or all elements of a row or column of a determinant. Some of the elements or all the elements of any row or any column of a determinant are expressed as sum of two or more terms. Okay? Any row or any column. All elements of any row or any column are few elements. Some elements are expressed as sum of two or more terms. Sum of two terms are sum of more terms, more than two terms. Then the determinant also can be expressed as sum of two or more determinants. Then the determinant also is expressed as sum of two or more determinants. For example, consider the determinant given in the left hand side. See the first row elements a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3. Here the first row elements, all the elements, not some elements, all the elements of the first row are expressed as sum of two terms, right? This is sum of two terms, a1 plus lambda 1. This is also expressed as sum of 2, a2 plus lambda 2. This is sum of a3 and lambda 3. Then, so if you have like this in the left hand side, then it can be expressed as sum of two determinants. Here suppose you have sum of three terms or sum of more than three terms, then you will be getting sum of three determinants in that case, or sum of four or sum of five, like that it goes on. Okay. So it is expressed as sum of two determinants, as we have sum of two terms in the first row. So A1, A2, A3, B1, B2, B3, C1, C2, C3 is the first determinant, plus lambda 1, lambda 2, lambda 3. This lambda 1, lambda 2, lambda 3. Then B1, B2, B3, C1, C2, C3. So using this property, we can array this result. We can write like this. So this is what property number 5 says. Let us see one example for this property. Show that for the determinant a, b, c, a plus 2x, b plus 2y, c plus 2z, x, y, z is 0. We have to show that value of this determinant is 0. Right? So consider the determinant, given determinant a, b, c, a plus 2x, b plus 2y, c plus 2z, x, y, z. Using the above property, I am going to write it as we have the second row elements, all the elements in the second row are expressed as sum of two terms, as we have sum of two terms in the second row. So using the above property, I can express this determinant as sum of two determinants, since we have sum of two terms in the second row. Okay. So this is A, B, C, then A, B, C again in the second row, then third row is X, Y, Z, plus the second determinant is ABC and the second row elements are 2x, 2y, 2z. In this sum we have two terms now, a and 2x. So we consider the second term for the second determinant. So 2x, 2y, 2z are the second row elements. Then third row is x, y, z. Now see the first row, first determinant. Here the first and the second row elements are identical. So what is the value of this determinant? It is 0. So without expanding it, we are writing the value as we have studied the properties of determinants. Then here you see the second row elements and third row elements. Here the second row elements are 2x, 2y, 2z. So 2 is a common factor. We can take it out. So we will be getting A, B, C, X, Y, Z, X, Y, Z. Okay. These two rows are identical. Therefore, value of the determinant is 0. So finally, you are getting 0. So using property 5, we have done this. Next, property 6. If to each element of any row or column of a determinant, the EQ multiples of corresponding elements of other row or column are added, then value of the determinant remains the same. That is, the value of the determinant remains same if we apply the operation. That is, here we are multiplying each element of any row or any column of a determinant by a non-zero value k. Okay, so here I am considering the row Rj, any row Rj. Each element of Rj is multiplied by the non-zero value k, and it is added to any other row, say Ri. Okay, then the value of the determinant remains the same, and it is expressed like Ri goes to Ri plus k Rj. It is applicable for column also. So how will you write that? Ci goes to Ci plus k into Cj. That is what property number 6. So if you are multiplying any row, here I am considering Rj by a non-zero value k and you are adding with Ri. So value of the determinant remains the same. and the operation is expressed as Ri goes to Ri plus K into Rj. If it is column operation means then Ci goes to Ci plus K into Cj. For example, if delta is determinant A1, A2, A3, B1, B2, B3, C1, C2, C3, and delta 1 is, here we are considering the third row elements C1, C2, C3, and the elements of R3 are multiplied by K and added to R1 means you are getting A1 plus KC1, A2 plus KC2, A3 plus KC3 in the first row, and the corresponding operation is here R1 goes to R1 plus K into R3. So the remarks are, if delta 1 is the determinant obtained by applying the operation Ra goes to K into Ra, RCI goes to K into Ci to the determinant delta, then delta 1 is K into delta. We can verify this result. If more than one operation like Ra goes to Ra plus K into Rj is done in one step, then care should be taken to see that a row that is affected in one operation should not be used in another operation. A similar remark applies to column operations also.